By the end of this lesson, you should be able to determine the difference between each of the conics, if I'm giving you a translated conic, as well as be able to identify hyperbolas and all of its features. So here is our standard form of the equation for the hyperbola. Notice that just like the ellipse, it has a equal to 1 at the end. It's set up just like the ellipse. The only difference would be that we have this subtraction sign in between. Now this hyperbola, which is not to be confused with the parabola, what it looks like is two parabolas combined together. Maybe that's where we get the hyper part from, two parabolas. And they could open up this way, or they could open up this way. And the way in which we're going to tell whether it opens up or down or left to right is by the variable that's in the front. The variable in the front will tell us where the vertex should be. Now this equation down here is the equation that we use to find the asymptotes of this hyperbola. This part is not as important as the actual hyperbola itself, but this is how we actually come up with the equations for the asymptotes. So here is a general equation for the hyperbola that opens up and opens down because that y is first. So our vertex is on the y. And this asymptote equation for the asymptotes is the opposite of the other ones because of the way in which our hyperbola is drawn. Now our asymptotes, what it does is it actually makes an x in between. These are our asymptotes, and that's what we use to draw the hyperbola. But remember that for this video, we're just focusing on the features and what they look like as opposed to the specifics of it. Let's graph this more concrete version of the hyperbola. So just like the ellipse, we need it to equal 1, so we've got to divide everything by 1. By 100 to get that equal to 1. And we reduce each one of those fractions just like we did with the ellipse. So that's going to be y squared over 4 minus x squared over 25 equals 1. And just like with the ellipse, these numbers underneath the x and the y will tell you where your point should go on the graph. So again, just like with the ellipse, we need to take the square root of both of them. So we get 2 and 5. So on the y-axis, because that 2 is underneath the y, we need to go up 2 and down 2. And on the x-axis, because that 5 is underneath the x, we've got to go 5 on the x and negative 5 on the x. And now, as opposed to drawing our ellipse like we did before, we're going to draw this imaginary box because this box will tell us exactly where we're supposed to draw the two parabolas, which are part of the hyperbola. And the hyperbola has asymptotes, and we draw those asymptotes by connecting the points on the diagonal on each one of those boxes. And these are asymptotes. Now, when we draw the two hyperbolas or the two parabolas, the way in which we draw them is we look at the letter that's first, which is the y, and that tells us that the parabolas should be on the y-axis. So our parabolas are going this way, up this way, and down this way. So we have asymptotes, and there is a center. The center is the center of that box that tells us where to go to draw the box. We have vertices, which are the vertices on each one of the parabolas, and then we have foci. And I will show you how to draw the foci or how to come up with the foci on the next slide. But our foci, again, just like with the parabola, is inside the parabolas. The hyperbolas have no covertices. This, which if you notice from the parabola, is the opposite of what we had in the parabola. The parabola was c squared equals a squared minus b squared. This one is a squared plus b squared. And I told you during the parabola that you'll know which one to use because it's the opposite of what's in the general equation. Remember the hyperbola? The hyperbola has subtraction. So if we look back at that equation that we had, the a was 25 and the b was 4, and we add that together and get 29. And then we take the square root of the c, and that's going to give us where our focus should be. And 29 is between 25 and 36, so it's between 5 and 6. So if I go back to that, or if I if I draw the focus on the hyperbola was at 2 up here and 2 down here, so it looks something like this. The focus is going to be between the 5 and the 6 of the units on the y. So it's 2, 3, 4, 5, so somewhere between here. And again, remember remember that we don't need to be that accurate. We can be, just general. We're just trying to understand that there is two foci and they're inside the parabolas, just like with the regular parabola. The hyperbola has the foci in. So if you find the C and all of a sudden your foci are over here, you know you did something wrong. Now we're going to talk about translating these conics and identifying them if I give you something that's not centered on 0, 0. Remember that everything before this has been centered on 0, 0. So we look at this general equation for the circle that's been translated, and it looks very similar to what we did before with that h and k. So this h and k are going to tell us where the center of the circle is. Just like with the parabola, this h and k and this h and k are going to tell us where the parabola's vertex is. Everything else is still the same. We still have r squared, we still have that 4p on the parabola, but now it's just going to be moved around the graph. And here's the ellipse in the hyperbola. Remember that there's a plus for the ellipse and minus for the hyperbola. And the letter in front tells us which way our hyperbola is opening. And the ellipse, remember there's a minor and a major axis depending on what these numbers are. But there is a center with the ellipse just like there is with the circle. Same thing with the hyperbola. Remember we make that box depending on where the center is. So now we need to talk about how do we know where the center is if they give us this very long, complicated equation. The way in which we're going to do that is we need to reorganize everything so that we bring all the x's together and we bring all the y's together. And then we have to complete the square in order to figure out what kind of conic it is and where its center is. So here we have a pretty complicated equation, but we can definitely be able to identify the conic and find its center by reorganizing things. So I want the x squared and the 2x together, and I want that y squared and 4y together. And remember with the conics, we want a single number to be over here. So we're going to subtract the 1 to the other side. And now we need to complete the square. We need to complete the square here, and then we need to complete the square here. So we've got to do it in 2 separate places. So remember when we complete the square, we take the b, which in the x case is -2. We take half of that, and then we square it. So half of -2 is -1, and when we square that, we get +1. And whatever we do to the left, we have to do to the right. Now we do with the y's. So b in the y's is -4. So half of -4 is 2, and then when you square that, you get, +4 is 2, and when you square that, you get +4. And whatever I do to the left, I have to do to the right. So now we simplify that. And remember when we complete the square, we factor this thing. Remember that half of b goes inside the factor, like that. So half of -2 is -1. And we do the same thing with the y. So half of 4 is 2, quantity squared, and then the right-hand side is 4 plus 1 plus 1, which is 6. And then if we look at this here, that's got to be a circle. A circle because even if I divide everything by 6, the two numbers underneath the x minus 1 and y plus 2 are still going to be 6. So it's the same number, which means it's a circle. And the center for this circle is at 1, -2. Remember, we take the opposite signs of the numbers that are inside the parentheses. So here we want to rearrange the x's together and then rearrange and put the y's together so that we can identify the conic and the center. So let's rearrange. So we get 4x squared, and then we move that 16x so it's near the 4x squared. And then we've got that -y squared minus 4y, and then move the -4 to the other side. Now we need to complete the square, but remember when we complete the square that we need that a to be 1. So before I can even complete the square, I have to factor a 4 out of this and a -1 out of this. So let's go ahead and do that. I take out the 4, And then I'm going to be left with x squared minus 4x. Remember, dividing 4 by 4 and dividing 16 by 4. And I do the same thing with the y's, taking out a negative 1. And then we get y plus 4y equals 4. And now I can complete the square. So remember, when we complete the square, we take half of b and square it. So half of negative 4 is 2, and when you square that, you get 4. We do the same thing over here with the positive 4. You take half of 4, which is 2, and square that, and you get positive 4. Now when we add it to the right-hand side, it's going to be a little tricky, because it's not just 4 that we're adding to the other side. In fact, what we're adding to this side is 4 times 4, because remember that 4 on the front, we would distribute that if this was a normal problem. The same thing over here with the positive 4. We're not really adding positive 4. What we're adding is negative 1 times positive 4, which is negative 4. So we need to represent that in the problem. 4 times positive 4 is positive 16. Oh, let's write that in a different color. So in fact, that is what I'm adding to the left-hand side and what I have to add to the right-hand side. And over here is negative 1 times positive 4, which is actually negative 4. So that's what I have to add to both sides. And then now we factor. So we get 4, and then we get x minus 2. When we factor that, remember that half of b goes here, minus 1, and then y plus 2. Again, because we take half of 4 and put that there. And then the right-hand side becomes 4 plus 16, which is 20, minus 4, which is 16. Now you might be tempted to think that that's a circle because we have a 16 over here, but we've got these numbers or these coefficients in front of the parentheses. So in order to see if it's a circle or a hyperbola or whatever it might be, we need to divide everything by 16. So let's go ahead and do that. Okay, so we had 4 and then x minus 2 squared and then negative 1 and y plus 2 squared equals 16. And we should be able to tell right away that this thing is going to be a hyperbola. And how do we know that? Well, the hyperbola is the only one that has that subtraction symbol in between the squared. Remember, that's sort of how I remember that it's a hyperbola. Now to find its center, we already have the center right there. It's at 2 and negative 2. And we get that from the opposite signs of these inside the parentheses. Now if we're going to actually graph this thing, then we're going to have to divide everything by 16 in order to figure out where to draw that box. So 4 goes into 16 4 times. We get x minus 2 squared over 4 minus y plus 2 squared over 16 equals 1. And then we would be able to graph that box because we take the square root of those two numbers, remember, and that gives us the edges of the box. So pause the video and try this one yourself. Okay, let's see if you did this correctly. So we need to move the x's around. So 4x squared, negative 8x, and then we've got the plus y squared. And then we have nothing, no other y, so we don't have to worry about that, but we do have to move that 8 over to the other side. Now because the y has no other y with it, we don't have to do any completing the square over here. That's already done. We only have to worry about the x part. So remember that we have to factor out that 4 because our a has to be 1 when we do completing the square. And then I take half of b and square it, so that's negative 1 squared is positive 1. And then I have to add something to the right hand side, and that's 4 times 1, which is positive 4. And now we factor. So 4 and x minus 1, remember half of b goes here, plus y squared equals 12. You should be able to tell that this thing is an ellipse. And where is its center? Well, the opposite sign of 1 is positive 1. And the y has nothing added or subtracted, so that's 0. So it's an ellipse, and the center is at 1, 0. So your homework is worksheet number 2, which will be on the blog in My Big Campus by Monday.